This video is about balanced and unbalanced forces and Newton's second law. So for this, I'm going to go about it two different ways. You can either know the forces and then use the forces to tell you what the motion is, and then if it's accelerating or not. And then the other way is, if you know what the motion is, you can use that to tell you something about the forces. So the first one I'm going to do is the easier one, where we know something about the forces and we can then talk about if it's going to be balanced or unbalanced. So Newton's second law. Oh boy, this is a squeaky marker. Woo! Newton's second law, let's try a different marker, says that the net force on an object is equal to the mass of the object times the acceleration of the object. Now note, it is not, well, I can't block it out from your point of view, can I? It's not force equals ma, it's the net force. The other way we see it written is it's the sum of the forces equals mass times acceleration. All right, so what does this really mean? What is this telling us? What it says is that if there's acceleration, then the forces, they must add up to something other than zero. So if this is zero, the acceleration must be zero. If there's no mass, you don't have an object of interest, and there's no point. So not worried about m being zero. Here, the sum of the forces, or the net force, if that is zero, the acceleration must be zero. That's what this says. So we talk about the sum of the forces equaling zero as being balanced forces. The forces all balance out, and balanced forces mean that the object doesn't accelerate. There's no acceleration. If there is a net force, or a sum of the forces is not equal to zero, let's just say it's 20, whatever, it's newtons, then we know that 20 newtons would equal mass times acceleration. We have acceleration. There must be an acceleration. So if we have unbalanced, oh, I hope this is visible. Yep, looks like it's visible. If we have unbalanced forces, then we have acceleration. The object must be accelerating. Balanced forces, no acceleration. The forces all add up to zero. Unbalanced forces, it is accelerating, and the forces do not add up to zero. So let's do a real quick version of very, very simple. If I have an object, our lovely little abstract object, and I have a force of 25 newtons going this way and 25 newtons going this way, are those forces balanced? Well, you look at it and you say, yep, that's pretty easy, right? So here, the net force, if you add up all the forces, well, we've got 25 to the right, we've got 25 to the left, that adds up to zero. These are balanced forces, which means this object is not accelerating. There's no acceleration. So what would the motion, what would the possible motion of this object be? Your first instinct? So give me your gut response. Just blurt it out. What do you think this no accelerating motion would be? Your first instinct is probably to say at rest. Absolutely. It could be at rest. There's another option. So think about what another option is for an object that has no acceleration. Could be at rest, but it could be doing something else. Give it a pause if you need to. See if you can come up with what it would do. No acceleration. The cruise control is on. The other option is constant velocity. So if we have balanced forces like this, then there's no acceleration. It can either be at rest or it could be moving at a constant velocity. So in this case, it could just be sitting there, boring, just sitting there, or it could be moving with a constant velocity. And so those would be the two options for balanced forces. So that was pretty easy, right? How about if we go 25 this way and we go 50 this way. You know, looking at that, they're not balanced. They don't add up to 0. So if we do the net force, it's going to be a plus 25 minus 50. The net force is a negative 25 newtons. Unbalanced. So the forces do not add up to 0, which means the forces are unbalanced. That means this thing has acceleration. It is accelerating, so has acceleration. Which way is it going to accelerate? Your gut instinct is correct in this one. Well, which way is the bigger force? Which way is the net force acting? If I've got 50 newtons tugging me this way and 25 newtons tugging me this way, I'm going to be accelerating that way. So, also, the net force tells us that. If we have a negative net force, that means the acceleration is in the negative direction. And so, a negative net force, negative acceleration. Now, this is something that's true for all forces that we're dealing with, but the key is that forces, we're going to split up how we look at forces. We look at them horizontally and vertically, and just like with projectile motion, we treat those separately. We treat them separately. So another version of this would be, let's say I've got 4 forces acting on an object. And what I've got is, let's go. Let's change these up, make it a little different. I don't know, 75 newtons here, 20 newtons this way, and 35 newtons up, 35 newtons down. Okay, so we have to treat x and y separately. So in the x direction and the y direction, we're going to do that. I just did that wrong. You didn't see that. You didn't see that. Y direction and x direction. So this is the plus x direction. This is the plus y direction. So we have to do this differently. We have to say, what is the net force in the x direction? And we have to say, what is the net force in the y direction? Okay, so we can do that. No worries. Let's just do what we did and say in the x direction, what do we have for our net force? We have a 75 force to the left and a 20 Newton force to the right. So this is going to be negative 75 plus 20, negative 55 newtons for our net force in the x direction. In the y direction, I've got a positive 35 going up. I've got a negative 35 going down. I end up with a 0. So in this case, what would we have? We would have something that's unbalanced in the x direction and balanced in the y direction. So here, no acceleration. And unbalanced means it's accelerating and we have a negative net force. We would have a negative acceleration. So the types of motion we could have, well, left, right, it could be at rest. While, oh, no, left, right, it could be moving this way. So accelerating this way, while up, down, there's no change. Let's say it's just v velocity in the y direction is 0. It's at rest, up, down, accelerating to the left. We could also have accelerating to the left, negative x direction acceleration. And we could have it moving upwards at a constant velocity. Or we could have it accelerating to the left and downwards, moving downwards at a constant velocity. Those are all options. So if we know the numbers of the forces, what we do is we look at the net force and say, okay, if the net force is 0, it's balanced, no acceleration. If the net force is not 0, unbalanced forces, we have a negative acceleration. So that is the way to think about balanced, unbalanced forces, with thinking if we have the forces, the numbers of the forces, before we know the motion of the object. The next video will be how to deal with balanced and unbalanced if we know the motion and then we want to go to the force, the net force. So that's the next video. Hope this was helpful.